In past years, whenever the number of passengers and the weight of luggage reached the maximum load-carrying capacity, the car developed a common automotive problem known as tail-end droop. Motorists experienced poor ride quality and vehicle handling characteristics since severe contact with the bump stops occurred more frequently. They also risked scraping rear body overhang when entering or leaving steep driveways. And of course, headlights were forced to direct their beams on everything between the road and treetops. But good news, Chrysler has beaten this tail-end droop with their new automatic height control system. Now, when this comfort and convenience feature is installed on a 1975 model and the car becomes fully loaded, the height control system takes over automatically without any attention by the driver. In a few seconds, the car body returns to the normal 3-passenger height position. Goodbye to problems with ride quality, handling, and headlight aim. At the heart of the system is the air compressor driven by engine vacuum. It's mounted to the left front fender just behind the headlight. Air pressure developed by the compressor is delivered to the small reserve tank, which is mounted forward of the left rear spring between the side rail and rocker panel. The brains of this system is the height control sensing valve. It's bolted to the underbody just forward of the rear axle. The sensing valve control arm and link is attached to this spring clip, which is installed at the inboard rear spring U-bolt. Changes in body height detected by this valve controls the amount of air pressure in these air-chambered rear shocks. Here are the airline fittings in the dust shield. Sealed air boots of heavy, durable rubber extend from the body of the shock to the dust shields. They mount the same as standard shocks. Now, here's how the units work. The 2-stage vacuum-driven air compressor supplies air pressure to the reserve tank when the engine is running. Nylon tubing, 1/8 inch in diameter, delivers the air pressure to all units in the system. This special tubing can handle up to 1,000 pounds per square inch without bursting. Now, as the pump operates, a diverter valve trips back and forth as the diaphragm is pulled to the limit of its travel in one direction and then in the opposite direction. This diverter valve simply opens and closes ports, which admit atmospheric pressure to one side of the diaphragm and vacuum to the opposite side of the diaphragm. Diaphragm movement trips the diverter valve, which opens and closes a different set of ports. This reverses the application of vacuum and air on the diaphragm, causing the diaphragm to move in the opposite direction. The diaphragm is connected to a pair of pistons that produce a pulse of pressurized air and send it through tubing to the reserve tank. A primary piston compresses the air first. Then the secondary piston takes this pressurized air and boosts it to a higher level. When pressure builds up in the reserve tank to a level of about 150 to 190 pounds per square inch, normal engine intake manifold vacuum acting on the diaphragm is not powerful enough to overcome high pressure in the tank and tubing, and the compressor stops operating. Only when reserve tank pressure is lowered will the pump resume operation. Anytime the car body moves downward to a position lower than the normal 3-passenger height position, the control arm transfers movement to a toggle, which forces the piston to slide in one direction. As a result, the control valve stem unseats the valve and admits pressurized air from the reserve tank to apply to the shock absorber feed line. Because of this, the shock absorbers start to extend. However, this action does not occur as quickly as shown. There's a time delay mechanism built into the sensing valve. Its purpose is to prevent road bumps or jouncing from making changes in car height position. It works very simply. Silicone fluid within this chamber slows down piston movement while the space between the piston and control valve stem permits the piston to slide a short distance before it moves the stem. This delays opening of the air passages up to 1 minute before the sensing valve either admits air pressure to the shocks or releases it. Therefore, rapid movement of the sensing valve control arm caused by road surface conditions does not affect air pressure within the shock absorber air chambers. Now let's continue to look at the action when the shocks raise the fully loaded car to the normal 3-passenger height position. As this occurs, the height control piston is forced in the opposite direction by the toggle. As it reaches a neutral or static position, air pressure from the reserve tank is blocked from entering the tubing leading to the shocks by the control valve stem. Applied pressure in the shock absorber air chambers is also blocked from escaping. However, once the vehicle load is removed, the toggle forces the piston to slide in the opposite direction, opening a port to permit pressurized air within the shock absorber to exhaust to atmosphere. About 15 pounds per square inch pressure is maintained in the air chambers, keeping the rubber air boots slightly inflated. This light air pressure reduces friction, chafing, and eventual wear between inner surfaces of the boots and the metal shock absorber body when the car carries loads of less than 3 passengers. That's a simplified explanation of the automatic height control system. Now, let's do some troubleshooting. Regardless of the problem, first check for air pressure in the reserve tank. Little or no pressure can be caused by a number of things. Start with a quick check of vacuum at the air compressor. Disconnect the vacuum line from the pump body. Normal intake manifold vacuum is vital. If okay, reconnect. Then check the air filter to see if it's plugged with dust and dirt. Clean as necessary and reinstall. Now, to verify compressor operation, disconnect the small fitting. With the engine running, place your finger lightly against the outlet. You should feel air pressure pulses when the compressor is working properly. If okay, press tightly to prevent air pressure from escaping. Doing this should cause the compressor to stop operating. However, if it continues to operate, there's an internal leak and the compressor must be replaced. If it checks out properly, reconnect the fitting. Be sure the tubing is all the way into the rubber air seal and flush with the end before attaching. Tighten securely. Check the tightness of all fittings at the reserve tank, at the height control sensing valve, and of course the shocks. Charge the reserve tank with about 100 pounds of air pressure. If you suspect a leak in the system, apply a soapy solution to each air pressure fitting. It's possible to have a tight fitting and yet have the tubing separate or leak under high pressure. If you locate a leak, correct it before proceeding with troubleshooting. The T-connection, other fittings, and the rubber boots at the shock absorbers should also be checked for air pressure leaks. Be sure the tubing is not kinked, does not rub against sharp edges, and all plastic clamps keep the tubing from making sharp-angled bends. To check height control valve operation, disconnect the U-bolt linkage clip from the rear axle by prying the rear section out, then the front section. Make sure there's at least 100 pounds air pressure in the reserve tank. Disconnect the air pressure tubing leading to the shock absorbers. Move the height sensing arm upwards. This simulates increasing the car load. Air pressure from the reserve tank should begin to exhaust from this outlet in about 1 minute. Some sensing valves may have a longer time delay. If air does not escape, lower the arm to the neutral position, and then back to the up position. Again, wait for at least 1 minute. If there's still no air pressure being released, the sensing valve assembly must be replaced. Reconnect the air pressure fitting leading to the shock absorbers. Then move the control arm upwards a few inches. Of course, be sure the reserve tank has at least 100 pounds pressure. Wait for the time delay mechanism to function. When pressurized air enters the rubber boots of each shock absorber, the car body should move upwards. If it does not, there's an internal leak in one of the shocks or an air boot is ruptured or split. If the car body moves upwards when pressure enters the air boots, lower the control arm a few inches past the neutral or centered position and wait once again for the time delay to function. If the car body begins to settle to normal curb height, the height control sensing valve is operating normally. While you're in this area, make a quick check of the height control arm setting. Without any pressure on the arm, measure the distance from the center of the linkage grommet to the upper wheelhouse, inside the frame flange. Specs call for 6 1/4 inches. When it's out of specs, loosen the adjustment nut. The control arm will move freely up or down without changing the neutral position of the nylon block. Set the control arm to 6 1/4 inches as shown. Then tighten the nut to 45 inch-pounds. Recheck setting. Reinstall the linkage clip. Place the front section on the U-bolt and tap it into place. Then the rear section. That winds up our diagnosis. Now for a few important points. When an owner is having a weight-distributing, equalizing type trailer hitch installed, review the details outlined in the operator's manual and reference book. Of course, trailer loaded weight and tongue loads must not exceed the recommendations listed here. Overloading, with or without a trailer, will damage the system. It's not meant to increase the load-carrying capacity of the car. Remember, it's a great feature for 1975, but certainly not designed to change a car into a truck. And in order to keep the automatic height control system in tip-top condition, recommend a yearly inspection of these units. Doing so will help to provide dependable performance of this new comfort and convenience accessory.